Hi! Welcome back to our class. So, kaning video atong i-discuss karon ang atong pinaka-last nga topic sa first quarter in the first semester in pre-calculus, which is about the sequences, series, and sigma notation. I know nga dili na ni siya bag-o sa inyo ha ang series ug sequences, but we will just have a short review before we proceed to the sigma notation. So, first is we're going to illustrate a series and a sequence first through this example. So, we have here a situation about Jason, whose classroom is on the second floor of the school. So, Jason can take 1 or 2 steps of the stairs in one leap. In how many ways can Jason climb the stairs if naa daw 16 steps ang hagdanan? So, makita nato din here as a figure. Imagine that this is Jason, the blue man. Okay, ang atong pangitaon karon is find the pattern in which pila ka paagi aron makaagi siya ng certain nga steps. So if you have one step in the stairs, so if you have this one only, what do you think? How many ways can Jason climb the stairs? Of course, there's only one. How about if you have 2 sa ikaduha nga ang? How many ways can Jason climb the stairs? So probably iyahang isa-isahon, 1, 2, and the other one, iyahang isahon. So we have 2 ways. How about if there are 3 steps in the stairs? Pila ka kapaagi nga makasaka si Jason sa stairs? So we have 3. So how about if 4? We have 5. And observe the pattern sa number of ways in climbing the stairs. From that, makakuha ka sa number 5 through observing the pattern. So we have 1, 2, 3, 5. Observe what happened. What do you think is the number of ways in climbing the stairs if naatay 5 ka steps? Okay, probably there are 8. And so on. So how did we obtain 8? So simply we just add 3 and 5. How did we obtain 5? Simply we just add 3 and 2. How did we obtain 3? Simply by adding 1 and 2. And this is a sequence, particularly the Fibonacci sequence. So I know this is very familiar to you. So from this, unsa daay ng sequence? Okay, the sequence is a function whose domain is the set of positive integers or the set of 1, 2, 3, 4, 5, and so on. And in our example, we have our domain 1, 2, 3, 4, 5, which is the number of steps, and we have here our function, which is y, which is our sequence nga na-result nga 1, 2, 3, 5, and 8. So that's how we define our sequence. On the other hand, the series is the sum of the terms of a sequence. So, kung mayon ganit tag series, it represents the sum of the terms of a sequence. So, if we are going to find the series here sa atong example, we will just simply add 1, 2, 3, 5, and 8. So, we have 2 types of series. The finite series and the infinite or the infinite series. So, kung intag finite series, mo ni siya kaning ipang-add lang nato ang pila ka terms kung asa ra siya taman. While the infinite series can be defined precisely in calculus. So, dinhaan na to mo gawas tong mga limits and so on. So, you will encounter this one in basic calculus in the second semester. So, let's proceed. There are people or there are students nga malibog gihapon kung unsay series o sequence. So, it's very easy to determine or to distinguish a series from a sequence. So, kung may nga taog sequence, the numbers are separated by commas. While the series, it can be separated by either the plus or the minus sign. But take note not all numbers separated by commas represents a sequence because in a sequence there is a pattern nga nung naana siya nga mga numbers. And take note of that. We have this example. Determine the first 5 terms of each defined sequence and give their associated series. So just like what I've said earlier, nga dili pasabot nga tanang numbers nga gi-separate by commas, nag-define na siya sa sequence. Because when we say sequence, there is a pattern nga gi-follow. So the patterns could be these 4 items here. So we have 2 minus n, we have 1 plus 2n plus 3n squared, we have negative 1 to the power of n, and so on. Okay. So let's answer number 1 and 2. So in determining the first 5 terms, ato lang i-substitute si 1, 2, 3, 4, 5 to the value of n. So we have 2 minus 1, 2 minus 2, 2 minus 3, 2 minus 4, 2 minus 5. And we have the resulting sequence 1, 0, negative 1, negative 2, og negative 3. So, other question is, give their associated series. So, kung pangitaan ta og series, we will just add the 5 numbers. So, 1 plus 0 minus 1. Okay, na minus 1 siya, kay negative 1 man ni. Then, minus 2, kay negative 2 man siya. Minus 3, kay negative 3 man siya. So, the result is negative 5. Okay, for number 2, the same process. Ato lang gihapong i-substitute si 1, 2, 3, 4, 5 dito sa values ni n. And we obtain the numbers 6, 17, 34, 57, og 86. So, the associated series is just, you're going to add all the 5 numbers and the result is 200. So, I will leave the number 3 and 4 for you to solve. So, kamo na solve ana niya. Okay, so we have different types of sequence in your associated series. I'm sure you are very familiar. You can actually makahatag mo sa ako unsa to mga types ng mga sequence. So the first one, or the very common, is the arithmetic sequence, in which na siya common difference. So kung pangitaan ta og unsa nga term, walang ni atong gamiton na formula. Its series is that's our arithmetic series, which is this one. So, natay duha ka formula nga gamitan. If given ang last term, kung gihatag unsa ang last term, pwede ra kani nga formula imong gamiton. N times the quantity of a sub 1 plus a sub n all over 2. Pero kung wala gihatag ang last term, pero gihatag ang common difference, we have this formula, n times the quantity of 2a sub 1 plus the quantity of n minus 1 times d all over 2. Okay, so that's arithmetic series. We also have the geometric sequence, in which na siya common ratio. So, you have this formula to find the nth term of a geometric sequence. So, ipamultiply lang siya. While the geometric series, naatay 3 cases. When r is equal to 1, just multiply the number of terms to the first term. Kung ang r na to is dili siya equal sa 1, so mo ni siya ang formula atong gamiton. Pero kung ang imong r is greater than negative 1 but less than 1, mo ni imuhang formula pagpangita sa series. And usually, this is associated with infinite geometric series. So, wala nahibaw kung pila ka terms, ka infinite man siya. Okay, last example for the sequence, we have harmonic sequence, which is just the reciprocal of the arithmetic sequence. So, this is naapay other example sa sequence of series, but mo lang ni siya akong i-present sa inyo. Okay, so let's proceed. So, determine kung arithmetic siya, geometric, Fibonacci, or O, if it is not one of the mentioned types. So, we have 1, 2, 3, 4. Okay, kindly inspect each item. Kung arithmetic ba siya, geometric, Fibonacci, or none of the mentioned types. Okay, so let's answer. Number 1, what do you think? 1, 3, 5, 3, 5, 7, 9, 11. Nasa kaya na siya nga sequence. Okay, as we observe, murag 2 lang ang diferensya nila. So, this one has a common difference. So, this is letter A. Number 2, 2, 4, 9, 16, 25. Makakita ba ta og pattern ani niya? I think dili no, dili wala pud siya common ratio, di pud common yang difference. So this might be an O. So wala siya sa mention natong hata. Wala dito sa atong gipilian. Number 3, 1/4, 1/16, and so on. Okay. Observe nato no nga gipang-multiply lang og 1/4 ang mga terms to obtain the second term or the next terms. So we have the geometric sequence. Number 4, obviously, gi-add lang nato si first and second term to obtain the third term, and so on. So this one is a Fibonacci sequence. So it's very easy to tell kung arithmetic siya, geometric siya, Fibonacci siya. So let's proceed to another example. Evaluate the series. 1, 2, 3, 4, 5, 6, taman sa 1,000. Sige daw. I-evaluate daw na siya. Okay, so this one, obviously, is an arithmetic series with a common difference of 1. When we add numbers, we will just use a certain formula to know that one. So, since arithmetic man siya, we will use the formula, this n times the quantity of a sub 1 plus a sub n all over 2. So, kanilang na formula atong gigamit since given man po ang last term, which is 1,000. So, since the common difference is 1, we can determine that our n is 1,000. 1,000 siya kabuo. So, by substituting the given, we have a sub 1 or the first term. A sub n is 1,000. So, we obtain 500,500. So, mo din siya ang sum. Okay. So, as you notice, it's quite troublesome. Charot. Murag taas siya kaayo kung inaani ang atong pag-plusar niya. Kanina ang answer. So, there is a way to shorten the expression of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus ellipsis plus 1,000. And this can be expressed using a sigma notation. So, din na mo pasok si sigma na to. So, this one, kani nga series, ma-illustrate nato siya using this sigma notation. So, ato siyang basahon as the summation of I from I equals 1 to 1,000. So, mo ni siya ayahang answer. So, unsa din ning sigma notation? So, by the way, sigma is a Greek letter. It's a capital Greek letter. Sigma. So, it is used to denote a sum. So, kung makita mo og kani, summation na siya. So, what is a sigma notation? So, let f of I be an expression involving an integer I. So, this expression can be compactly written in sigma notation. So, pareho itong ganina, 1, 2, 3, 4, 5. Ma-express nato siya in a shorter expression, which is with the use of the sigma notation. So, we have different parts of the sigma notation. So, kanina siya, manigitawag na to nga summand. Anong summand? Summand. Okay. So, muna siya atong ipang-add, no? Or the expression nga ato ang gamiton. We have the I, kaning I, muna gitawag na to nga index. We have the M, which is the lower bound. Muna siya ang beginning, so lower bound, while the N is the upper bound, or kung asa ra siya taman. So, this symbol, kani, muna ni siya ang ato ang muna ang sigma, uppercase siyang sigma. Ang lowercase ng sigma, if naka-remember mo sa symbol sa standard deviation, sa population, or katong variance, ay paday mo ana, sa stat paday to siya. So, mo siya ang sigma nga small letter. So, this one is the capital letter sigma. So, basahon na to siya as the summation of f of I from I equals m to n. So, here, m and n are integers and m is less than or equal to n. Okay, so let's have an example. I-expand nato ang summation and we will simplify if possible. So, we have the first one, the summation of 2i plus 3 from I equals 2 to 4. Number 2, the summation of a sub I from 1 to n. We have number 3, the summation of the square root of n all over n plus 1 from n equals 1 to 6. So, ato siyang ipang-expand. So, how are we going to expand this summation? So, first, simple lang atong buhaton. We will just substitute the value of I. Sige, ingon na to diri nga value ni I from 2 to 4. So, meaning the values of I could be 2, 3, and 4. 2, 3, 4. Duha pa lang siya. Tulo lang kabuok numbers. So, ato lang siyang ipang-substitute. So, we have here 2 times the quantity of 2 plus 3 plus 2 times 3 plus 3 plus 2 times 4 plus 3. And simplify them and you have the answer 27. So, kanina siya, this is equal to 27.